Welcome to qnawire.
So we have 1-chloro-1,2-diphenyl ethane, which we know undergoes an E2 elimination reaction to give us either the cis or trans isomers of 1,2-diphenyl ethylene. So from this statement, we see that we have two different isomers for our product. And from this, we can infer that we should have two different isomers of our reactant as well. So I'm going to go ahead and draw the two different isomers of our reactants and kind of assign which is going to be the cis and which is going to be the trans. So when I draw the following here, draw the following here. So I'm going to draw this phenyl group over here as a wedge. And then over here, I'm going to draw this phenyl group as a dash. So notice how this particular phenyl group is going away from us with the dash, and this phenyl group is going towards us with the wedge. So from this, we can conclude that when an E2 elimination reaction occurs, they are going to be on opposite sides, and we're going to get the trans-alkene product, and that is going to look like this. I'm sorry, that. All right, so this is going to be our trans. Oh, sorry. There should be a hydrogen right here. So as I was saying, this is going to give us the trans isomer of our product. And when I draw it like this, so what I did is I simply rotated this bond, the carbon-carbon bond, to look like the following. So I'm going to keep this phenyl group as a dash here. And what I'm going to do is what happens when that bond is rotated is we're going to get another, or this phenyl group is now going to become a dash as well. So when we have our two phenyl groups that are both going away from us, when we perform an E2 elimination reaction, we're going to get the following. We're going to get the cis isomer of our product, which will look like the following. All right. And now the question asks us to draw the Newman projections that will lead to these products. And we want to explain why the trans-alkene is going to be the more predominant product. So why don't we go ahead and draw the Newman projections for each. So I'll go ahead and draw the first one here. So we are going to draw that. So for our front carbon here, what's facing up is our chlorine, and on our left is going to be the phenyl, and on the right is going to be the hydrogen. For the back carbon, top left is going to be hydrogen, top right is going to be phenyl, and bottom is going to be the hydrogen. Well, notice this is going to readily undergo an E2 elimination reaction. We see that we have a reacting chlorine and hydrogen that are anti-paraplanar to each other, which is perfect. So a base is going to come in here, deprotonate that. This bond is going to get shared between the two carbons, and our chlorine is going to leave. And that the following Newman conformation, Newman projection is going to look like this. All right, so for the front carbon, which is the dotted carbon, So for the front carbon, which is denoted by the dot, we are going to have phenyl group on the left, hydrogen on the right. For the back carbon, we are going to have hydrogen on the left and phenyl on the right. So when I circle our phenyl groups here, we see that they are on opposite sides. So this is going to give us the trans. So I'm going to go ahead and draw the Newman projection. Oops. I'm going to go ahead and draw the Newman projection for the second cis isomer, what is that going to look like, right? So we're going to go ahead and draw that. So for our front carbon here, our top is going to be chlorine, and phenyl is on the bottom left, and hydrogen on the bottom right. Now this conformation is a little bit tricky because we actually have an eclipsed conformation. So these bonds are going to be overlapping in space. So the hydrogen is going to be overlapping here, hydrogen is going to be overlapping here, and our phenyl group is going to be overlapping here. So whereas our, this is a little bit tricky for an E2 elimination reaction, because whereas in our previous Newman projection, we saw that the hydrogen and chlorine or chloride were antiparaplanar to each other, here they are overlapping with each other, and this is actually much harder to undergo an E2 elimination reaction. But we can go ahead and draw our E2 elimination reaction anyway, where this is going to deprotonate this hydrogen. These electrons are going to get shared between the two carbons, and the chloride is going to leave. And the following, we get the following Newman projection. So we're going to have our, for the back carbon here, we're going to have the phenyl group on the left, hydrogen on the right. Same thing for the front carbon, phenyl group on the left, hydrogen on the right. We see that our phenyl groups are on the same side. So we would say that that's going to result in the cis alkene. And now we really want to understand the reason why we get trans as the major. So one of the reasons, as I explained earlier, is the antiparaplanar requirement for E2 elimination. But we can look at our Newman projections and see that for the trans isomer, that we have a staggered conformation, because this is actually the lowest energy conformation. All the bulky groups are opposite to each other. So our phenyl groups are our bulky groups, and we can see that they are opposite to each other. I circled them in blue here, right? And then for our cis isomer, we see that our big bulky phenyl groups are overlapping each other. Results in the highest energy conformation, which is the eclipsed conformation. And this is why we would say that our trans isomer is going to be the major product.